Okay, so we are going to talk about the heart and the circulatory system today, all right? Circulatory system. All right, so what is it? It is a system that does that. Transports oxygen, nutrients from your, intestines, stomach, intestines, down there, all right? And other substances throughout the body, including waste products and the reverse. So carbon dioxide out, waste from tissues, okay? It is the transport network of your body. Now there are other ducts, D-U-C-T-S, not ducks, quack, quack, ducts, like duct tape. Everyone says duct tape. I don't know. Anyway, there is a brand called that. But these are the ducts that transport all those things through your body. So what is the center of the circulatory system? We know what that is. Yes, very good. It's the heart, el corazón, okay? And it functions as two pumps. So you've got four chambers, ventricles and auricles. I don't think we have to know that, but one pump pushes blood to the lungs, and the other pushes blood to the rest of the body. So it's quite an efficient system, actually, okay? And we do not have blue blood, okay? Let me make that very clear to you. Even though, in your veins you see like a blue color, that's just the light playing tricks on you, pretty much. We have two different colors. We do have two different colors of blood. One is more of a maroon color, like a burgundy. That's the unoxygenated blood. And the other one is bright red. That's oxygenated blood. So if you see somebody bleeding and bright red blood is coming out, they have severed an artery, which is blood going to the rest of the body. And if they have severed, if there's dark blood like oozing out, then they have severed a vein, and that's blood that's going back to the lungs to dump its carbon dioxide waste and get the oxygen back into it again. All because of the movement of this pump. It's amazing. It's natural contracting muscle in your heart. It's a special kind of muscle called cardiac muscle that just works your whole life. It's just amazing. It's incredible. So, as I was saying before, arteries, okay, so there are parts. The arteries are the first one. These are larger blood vessels. They have very thick walls, and they carry blood away from the heart to your brain. You have the carotid arteries in your neck. You have lots of arteries that go down to your legs and down to your arms, to your organs in your body. And they, like I said, they have thick elastic walls because there's a lot of pressure coming from, you could feel, you feel your pulse in your wrist. That's a lot of pressure, pumping, pumping, pumping. And then the veins, they go in the opposite direction. And these are very unique as well. Veins have valves in them, okay? So in an artery, you don't need valves because you have pressure and it's going in one direction. So going from your heart down to your legs. But in a vein, that blood has to get back up from your legs to your heart. And so it has these valves that only allow flow, for the most part, in one direction. Because gravity will want to pull that fluid back down again. So as it's being pushed through the veins, it won't fall back down. And a way to help increase your circulation in your body is to be active. Not always. Obviously, we have to sit at the computer or read or, watch TV once in a while, or sleep. But people who are sedentary, that means they sit all day and do nothing for the most part, except go to the refrigerator or the toilet. Those are the ones who are going to develop circulation problems. So you always should be active, walking, biking, playing sports, doing something like that on a daily basis, so that you can keep these healthy, okay? Your blood is always red, remember, there's no blue blood. I said that already. That's a misconception. That's an old wives' tale, so to speak. And then you have capillaries. Now, capillaries are arteries and veins, but they're tiny, very tiny, okay? So these are the smallest blood vessels. These blood vessels pass blood cells pass through them in virtually single file, or maybe 2 cells at a time, okay? It'd be like, a great big hallway here in the 8000 building compared to trying to get through the stall of a bathroom or something like that, where only one person can pass at a time, It's kind of like that. So, or a doorway, So they have very thin walls, and the thin walls allow oxygen and nutrients to literally pass through them, through the wall. Veins and arteries, that won't happen in, but because they're too thick, right? Veins and arteries, see how thicker in comparison to the vein? And this is where the transition between the two take place in these smaller vessels called capillaries, very tiny. Allow carbon dioxide, other waste products to move from the tissues into the bloodstream and carried back out to the heart and the lungs and places that process wastes, like your liver, and then your kidneys filter the blood, and then it gets passed out, okay, through your waste. And your lips have a lot of capillaries, that's why they appear red. Some people have more. When you get flushed, when you get embarrassed, if you have lighter skin or darker skin, you can see it too sometimes. Your face gets red. That's because the capillaries expand and allow more blood to flow, and that's what makes your face red. And this is broken capillaries on someone's skin. Maybe they got slapped, okay, or something like that. That will break your capillaries. A hickey is bad because you're literally rupturing your blood out of the capillaries and into your skin, which is not very healthy, is it? Okay, so label that in your notes: arteries, veins, capillaries, okay? Maybe some of you did that already because you were on top of your game. All right, so what is your blood made up of? Well, 55% of it is water, okay? Mostly water. Plasma is mostly water. So we are big bags of water. If you take all the water out, we would be this like little pile of dust, not much bigger than that, if we took all the water away from us. And in that water, 55% of your blood, okay, called plasma, are dissolved gases, salts. That's why if you ever tasted blood in your mouth or blood in your nose or bit your tongue, it tastes kind of salty and metallic, almost like iron, like you licked an iron pot or something, like you had a spoon in your mouth or whatever. Or not a penny. Pennies are copper. Iron is different. That's the salts. That's the, you need iron in your blood. Iron is where the oxygen binds to. It's not a salt. It's I don't know what you call it here. It's not even a nutrient. Yeah, I guess it's a nutrient. Yeah. It's not an enzyme, not a protein, not cholesterol. It's not a salt. It's not a gas. It's got to be a nutrient because you need iron in your food. So yeah, it's a nutrient. Anyway, long story short, on your red blood cells, there's iron in there, part of a molecule called hemoglobin, and that's what oxygen binds to carry it through your body, okay? And red blood cells are pretty neat because they don't have a nucleus. It's the only cell in your body without a nucleus. They don't need it. They only live for like 3 days and they die. Your body's constantly making new red blood cells in the long bones of your body, like your femur here and your upper leg and your humerus, in the bone marrow. That's where red blood cells are made. It's pretty wild how everything works together. So the red blood cells don't have a nucleus, but they're still considered eukaryotic cells. White blood cells, about 1%. And we talked about those in the immunity portion of the notes, and how they guard against infection and how there's different kinds. Remember, there's the macrophages and the leukocytes, okay? And then the platelets. The platelets are what cause you to stop bleeding when you get a boo-boo. So my cat recently, I just had to trim her nails. She likes to play rough, so she sliced me open there, and it was dripping. Drops of blood were coming out. Now, if I did nothing at all, would I just continue to bleed to death from that little tiny cut? No, because platelets come in and they have a clotting material that stops the blood from flowing. And that's a good thing, because otherwise you'd be like a hemophiliac. We learned about in genetics that they don't have that blood clotting feature in their blood, and a little slice you could bleed to death. Just won't stop bleeding. Let's see. So how is your blood flow measured? Now, you've probably been to the doctor before. Gosh, I hope so. And you've had your blood pressure taken as a normal procedure for checking into the doctor's office. And typically in young people like you, blood pressure is never a problem. But when you get into an accident or something traumatic happens, or you see something, you're in shock, your blood pressure can change, okay? Or if you stand up really fast from laying down, you stand up really fast, your blood pressure could take a moment to get regulated, and you could actually pass out. It happens to some people sometimes. So the two things that they measure are the systolic and the diastolic parts. Okay, and so systolic is when the heart beats, thump, and then when the heart contracts. This is the contraction of the muscle, and then this is the relaxation of the muscle, diastolic, and it's given in a fraction. Okay, so it's systolic over diastolic, and I guess the way to remember that is numerator is on top, and denominator with a D is on the bottom. So you always know that the D word is on the bottom of the fraction. And it's not really a fraction, it's just a comparison. There's no math going on here. So, it just gives you, so high blood pressure would be something like that number. That's hypertension. Prehypertension is this range, and then normal blood pressure is anywhere around 120 over 80, somewhere around 110 over 85, 75. Any range close to that would be normal blood pressure, okay? Now, there are other things that this is indicative of. I am not a cardiac doctor or surgeon or nurse or anything like that, so you'd have to look more into that to find out what else I can tell you. But if I was an EMT, not an EMT, but a first responder, which is one step below an EMT in the fire department, so there are certain things, if the blood pressure is low or high, you can determine whether, you can help diagnose somebody. So are they having, are they in diabetic shock or something else going? Did they have blood loss and the blood pressure is low, and so on and so forth. So there are things that you can tell from blood pressure outwardly. Okay, so factors that affect your blood flow. Okay, so here are some important terms that you should know. Viscosity. So viscosity is the thickness of the blood. So something that's thick, like this honey here, that you'd call that viscous, or oil for a car. You may have heard of the viscosity of the oil in the car, okay? And less viscous is something like water. So that is a way to measure blood flow also, how viscous it is. That's a word you'll learn in, if you take chemistry also, you'll learn that in chemistry class. Physical science, you actually should have learned that word also, viscosity. Coronary artery disease, narrowing or blockage of the coronary artery is usually caused by something called atherosclerosis, not arteriosclerosis, atherosclerosis. And it's hardening or thickening, clogging of the arteries. So this is a buildup of material that restricts the flow of the blood through the artery, okay? And that can rupture. It could cause, if it gets constricted too much, it could cause circulation problems in the extremities that could change the color of your skin, and then eventually if you get a wound down there, it won't heal properly because you need good blood flow to heal. And then you could lose your toes, you could lose your foot. This is I'm talking about people with diabetes, people who are elderly or older people, although it could happen in younger people as well if they don't take care of it. It's very rare to happen in a young person. But the more bad food you eat, the worse your diet is. The more fat you eat, the more sugar you eat, the worse this kind of thing can happen, okay, can get. So it slowly builds up and restricts the flow, okay, of the artery. Atherosclerosis, or hardening of the arteries. And there are ways that this can be fixed. Diet is number one. Diet and exercise are the two most important things you can do to prevent this from happening, or to prevent it from happening a second time if you had it happen the first time. But there's also physical things they can do. They can go in here and they actually like ream it out with this tool, and it breaks this up and opens up the vein. They also can put something called a stent in there, where it's like the sleeve that they get inside, and it keeps the wall, if it's weakened, open and flowing. But it's not a very good permanent solution. These are temporary solutions for this problem. Diet and exercise, okay? If you don't want your arteries to look like this when you're in your 30s, diet and exercise, okay? And then you'll be dead by the time you're in your 40s if you don't do anything about it. Okay, so these are factors that affect blood flow, and it's kind of easy to read if you take some time to look at this, okay? And when we are looking at this, you're going to realize that there are some direct relationships and some inverse relationships. So let's look at them one at a time, okay? So this is the response of blood flow if the factor decreases. So if blood pressure decreases, blood flow decreases. Okay, that is a direct relationship if they're both doing the same thing. If the blood volume decreases, the factor decreases, then blood flow also decreases. Again, another direct relationship. And the opposite is true. Increase, 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 okay? If you decrease your exercise, you're going to decrease your blood flow. All direct relationships. And the opposite holds true for that as well. Now down here, viscosity, or that thickness, if that decreases, blood flow increases. And vice versa. Inverse relationship, okay? If coronary artery disease decreases, diet and exercise, your blood flow increases, gets better, okay? Trust me. My father is dealing with this issue right now because he didn't do well with his diet and exercise for his life, and now he's suffering from it. All right, so how does your body maintain homeostasis based upon some of the things we're talking about here? So, you know that activity requires more energy, and we get that energy from the food we eat, and the food we eat gets converted into that molecule called adenosine triphosphate. So, activity, therefore, requires more ATP, okay? So during exercise, your muscles require more oxygen to make more ATP through cellular respiration. They also produce more waste in the same turn. Now me, because I am an amputee, I actually use more energy and more oxygen to just simply walk, because I don't have all the muscles that a person with 2 feet has. So I have to use my other muscles twice as hard to propel me forward, okay? So my activity requires even more ATP than your activity. As a result, your heartbeat and blood pressure increase to maximize flow. That's why when you're exercising, your heart rate goes up. Makes total sense, right? Because you've got to get more oxygen to those muscles to do the work that you are putting them through. Same with your brain. When you are studying, reading, doing something that's brain activity heavy, your brain uses just as much oxygen as your muscles do. And so you will get hungry studying, reading, creating, making things, okay? Building things, solving problems, solving things, okay? Not just math and homework, but fun things as well. Trying to solve, problems. So you will also use more oxygen that way as well to keep your brain moving. Not moving, hopefully your brain doesn't move, but working properly. How does your body continue? So low blood flow due to heart disease, right? We talked about this already. The blood pressure will increase. If you squeeze a tube, you're increasing the pressure. We've all done this with like a hose or something like that, where we kink it and then you let it go and the water shoots out in higher pressure, but then it reduces again. So we know this. Or if you step on a hose, something like that. Chronic high blood pressure can do these things: damage and weaken brain blood vessels so that they actually burst. And that's called a stroke. Well, it's called an aneurysm. A stroke is a stoppage of blood flow to a certain area of the brain. And blood clots, that's the blood clot stroke part, okay? So damage and weakened brain blood vessels, either one is bad. Oftentimes people die immediately from things like this. It's like all of a sudden they're fine and then they're done from stuff like that. So you do not want to develop heart disease. And what are the 2 ways to do it? To not develop it? Diet and exercise. Stop eating fast food all the time. Once in a while, no problem. But if you are eating it all the time and eating all those sugary things and those sugary energy drinks all the time, especially in your stage of development as a teenager, as an adolescent, before you even reach adulthood, you are affecting your body for the rest of your life by choosing what you eat now and how much exercise you get now. So what happens if homeostasis stops working, okay? Well, it's pretty simple. You're going to get sick. Disease necessarily doesn't mean like you catch a disease like COVID or a cold or something like that. No. Just like heart disease, okay? Or you die, like I just said, like fast, all right? So traumatic injury, a patient has lost much of their blood volume due to internal bleeding. As a result of low blood volume, blood pressure goes down. If surgeons cannot repair the damage in time and probably replace some of that blood with a donation of blood, the patient's injuries will become fatal. All right, and that's our notes. On to the next thing.